Thank you so much, Pia, and it's an honor to be with all of you here today. So my name is Guðmundur Ingi. I studied environmental science 20 years ago, and I think if I want to share just one thought with you before we start, it's that I think that utterly little has changed during these 20 years, unfortunately. And as we move on to the next theme, I think that's something we might want to keep in mind. But the extinguished panelists are Þorvarður Árnason, director of the University Center in Hornafjörður, University of Iceland, John Holdren, who we have already heard from. John, I'm not going to introduce you again. Guðfinna Aðalgeirsdóttir, professor of Glaciology at the University of Iceland. Guys, please come up. And finally, Hanne Christiansen, who is a professor in physical geography at the University Center in Svalbard and UArctic chair in permafrost physical processes. Guys, please have a seat. And I think we will just maybe start trying to connect the two sessions, because that is always good, to make connections between what is being said. So therefore, John Holdren, I think I will ask you to start, and then the other three will give their opening remarks. We heard here more than one people in the last panel, and in your good introduction or keynote, that what happens in the Arctic doesn't necessarily stay in the Arctic. So could you please, with your distinguished experience from both science and impacting policy on a very high level, tell us what you think are the implications of what is happening in the Arctic, in particular when it comes to the cryosphere. What are the impacts globally?
Well, when I think about what's happening in the cryosphere in these three domains, permafrost thaw, sea ice retreat, and land ice shrinkage, I think of this problem that I mentioned in my opening remarks, which is really that most people in the world don't understand why the Arctic matters to them. They don't really understand that what's happening in the Arctic isn't staying in the Arctic in ways that influence the well-being of everybody on the planet. And the three domains of the cryosphere that we're talking about here are particularly vivid examples of how that happens. Permafrost thaw, I already mentioned. Permafrost thaw is putting methane and carbon dioxide into the atmosphere. That methane and carbon dioxide are globally mixed greenhouse gases. They are contributing to the global rate of warming. And the magnitudes, now being closely investigated by scientists all around the Arctic, are such that our current best estimate is that those emissions from Arctic permafrost will take a bite out of the global carbon budget, the amount of carbon that activities of civilization can release without exceeding 2 degrees Celsius of global average warming, a bite in the range of 10 to 20%. A 10 to 20% bite out of the global carbon budget influences everybody all over the world. It tells us, all of us, that emissions from human activities directly must be more sharply released than we thought. And it tells us that the investments we make in adaptation must ramp up faster than we thought. Secondly, sea ice retreat. Sea ice retreat, while having enormous impacts in the region, is also exporting impacts across the northern hemisphere through the alteration of ocean currents and atmospheric circulation that are producing, among other things, changes in extremes of weather across the northern hemisphere, and including changes mentioned before as a possibility, but now I must tell you a reality, changes in the monsoons in India in ways disadvantageous to the population of that enormous country. A third, land ice shrinkage. the loss of ice from Arctic glaciers and the Greenland ice sheet is now known to be the single largest contributor to global sea level rise. Everybody around the globe who lives on a low-lying coastline is now concerned about sea level rise. Most of them have no idea that the single most important driver of that sea level rise is coming from the impact of rapid climate change in the Arctic, which in turn is driven by everybody's emissions around the world. Those are the points that I would like to see more emphatically emphasized for the benefit of decision makers around the world and publics around the world.
Thank you so much for this, Professor Holdren. And I think it's a good start for the panel. And before I invite the remaining panelists to give their opening remarks, I'm just going to remind us that we are talking about the cryosphere in crisis and impacts on Arctic communities, but in a much bigger, broader, global sort of scale. So, Þorvarður, would you give us the honor to be the next one to give some opening remarks? Go ahead.
Yes, thank you, Guðmundur Ingi, and I also thank for the honor of being chosen to be in this panel. I was a bit torn coming into which hat to use when I answer this or make this opening statement. Should I speak as an academic? Should I speak as a communicator? Or should I speak as a representative of my community? To explain the last, I adopted the community of Hornafjörður almost 20 years ago, where I've been living and working. And I now feel myself to be a member of that community very strongly. It was mentioned here earlier, I think by Gunnar, that we don't have any indigenous peoples in Iceland except maybe ourselves. But I do feel that over the last 2 decades I have become gone native, especially through the actions of my youngest children who have found life partners in Hornafjörður and are now have provided me with 4 grandchildren that are born in Hornafjörður. So I have, during this period, I have, the community has grown into me and I've grown into the community. But probably, though, the single most important reason why I am still living in Hornafjörður are the glaciers. It's the impact of the cryosphere. Because Hornafjörður is sort of nestled just below Vatnajökull ice cap. And from where I work, I can see 6 or 7 outlet glaciers. I can see Öræfajökull, and these are a daily part of my life. So when talking about the crisis of the cryosphere, the first thing that comes to my mind, of course, is the rapidly melting glaciers that I see and have become an eyewitness to their down-wasting over the last 20 years. And what does this mean for me personally? On a local level, it is maybe about the diminishment of nature. It's about the destruction of a very particular kind of beauty. It's about the gradual dimming of the landscape. One of our most famous poets, Steinunn Sigurðardóttir, published a book of poems a few years ago, 2019, which are all dedicated to climate change. And Steinunn, she knows Vatnajökull very well, and one of her core messages was that this luminous landscape of ice and proglacial lakes and snow, this was in a period of twilight, or gloaming, that this was disappearing. And the light, this particular light, would be lost from the world. So So this is just one aspect. This is something that I can speak to on a personal level as a member of my local community. But obviously, we need somehow to make sense of these local stories, local conditions, local experiences in a global context. And to do so, we need to be able to communicate with one another, I think especially those of us who live in the Arctic. Thanks.
Thank you so much, Þorri. Now I will slowly go from being very formal and saying professor this and that to calling them with their first given names, because that's how we do it in Iceland. Sorry about that. So, Professor Christiansen, Hanne, go ahead.
Thank you. I'm going to introduce a little bit my world of permafrost to you. And when I think about permafrost in the cryosphere, it's often the most overlooked part, even though we've just heard how it's globally important. And that's, of course, because you can't see it. It's not very sexy. It's not like glaciers. It's not like sea ice. It's something that just sits there in the ground. But believe it or not, there's 5 million people that actually live in areas around the Arctic that has permafrost. And oops. And many of them actually have their house or their infrastructure on permafrost. So this is, of course, why this matters. And I'm sure you all know what permafrost is. It's permanently frozen ground. Well, that can be rock. It could also be sediments, and sediments can contain a lot of ice. And then if you add climate change, you start thawing the permafrost, it will become water. You just seen how that can be a problem. And that becomes a problem in society at a much larger scale, of course, because you grow thicker active layers. This is the layer that sits on top of the permafrost that thaws and freezes on an annual basis. And when we have climatic changes and the warming of an area, it means two things to the permafrost. It means that the active layer is getting thicker, but it's also active, which means thawed in a much longer period of time. The shoulder seasons become longer, and this means that we can have action in the Arctic landscape for much longer time. And if so, that actually increases the risk of landslides, it increases the risk of the interaction with infrastructure that sits on permafrost and so on. Now, I'm a physical geographer by training, and I used to do very basic research on permafrost. And within the last 10 years or so, I've shifted my research interest to being much more applied permafrost researcher, but also now working very much interdisciplinarily. And this is, of course, because you can't solve the issues of thawing permafrost for societies if you're just doing basic research alone. So right now, in Svalbard, where I've been doing research on permafrost for the last more than 20 years, we are now developing tools, and we call them permafrost climate change response systems, that can enable us to collect all the data that is important about permafrost, all the knowledge that we need, and that's, of course, permafrost temperatures, it's active layer thicknesses, but it's also maps and so on, so that we can model what will happen in the future. But it's also interviews with the decision makers and people who live in the area and understand what is it that they actually need in order for us to develop the right tool, with the ambition being to be able to say, okay, now this is what you need to think about when you do long-term planning, area planning on permafrost, or this is what you need to think about if there's a rainstorm coming in, and is it actually now that we have active layers that could be active? So these kind of tools need to be developed, and when doing so, I work with social scientists, political scientists, engineers, natural scientists, but we also have an ambition to do citizen science and actually involve the people living there to tell us what do they want to contribute with, what do they think is important to know. And finally, this is, of course, also quite important for education. So believe it or not, there's very little permafrost education in the world, and this is something we really need to have more of. But I think I'll stop there.
I was just thinking when you were telling us that permafrost is not visible, basically, obviously true. I would love to see permafrost, put it on the table for everyone to see, because that is basically what we see here in Iceland outside of almost no matter where we live, we see a glacier. I saw 4 when I grew up. But anyways, Professor Aðalgeirsdóttir, or should I address you differently? The floor is yours.
Thank you. Yes. So thank you for the invitation to participate in this panel. So it's very interesting to be here. And when I was preparing for this discussion, I reflected a little bit on the path that I took to be here today. So I grew up in Akureyri on the north coast of Iceland, and in the 70s and 80s, it was quite hard winters and a lot of snow, and that got me into skiing and interest in glaciers. So when I came here to Reykjavík to study geophysics at the University of Iceland, I got drawn into working on Vatnajökull, the largest ice cap in Iceland, and I got infected by the glacier bug. So we have this specific glacier bug that we probably all are infected with here in Iceland. And then I became a student in Alaska, and I was fortunate to fly over many of the glaciers in Alaska and Washington State in a small airplane, and we measured the elevation changes compared to maps that we created during the International Geophysical Year in 1957. And this 1957 to 58 year was a year that sparked many new observations in the Arctic. And then we compared those elevation measurements to those maps and estimated volume losses of Harding icefield and its sea level equivalent. And this was only a fraction of a millimeter, but in 1997, it was more of a thought experiment than a genuine concern. But time has passed, and the importance of the Intergovernmental Panel on Climate Change has become clear. It is drawing attention to the response of the world's glaciers and ice sheet to global warming and revealed their unequivocal contribution to sea level, and the very urgent need to change our energy resources away from burning fossil fuel. And I was working in the Danish Meteorological Institute in Copenhagen during the COP15 in 2009, the meeting when the agreement on limiting the warming to 1.5 degrees was expected but failed. And at this time, we were working on integrating the Greenland ice sheet into the climate models, since the 4th assessment report of IPCC revealed that the ice sheets were indeed responding rapidly and raising sea level at increasing speed. And then after I contributed to the 2021 6th assessment report, it became clear in my mind how important it is for scientists to play a leading role in the conversation about the impact of climate change on glaciers and sea level, and emphasize the consequences of inaction. So to me, this is quite a daunting task, and I think the only way to accomplish this is through international and interdisciplinary collaboration, and keep the focus on reducing emissions as fast and as much as we possibly can.
Thank you, Tolly. We've heard from all of you now, and you guys are have shared with us where you're coming from, a little bit of what you're doing. What I want us to discuss a little bit in more detail now is basically how interdisciplinary research, which all of you have been involved in one way or another, and cooperation can really support Arctic communities, what we could say on the front lines of environmental transformation. So if I start with you, Tolly, you mentioned the IPCC, and if I remember this correctly, in the latest report, they say that it's virtually certain, or more than 99% certainty that the Greenland ice cap is going to melt, and sea level rise will happen. Mm-hmm. So no new news to this audience, but it's more than 99% certainty. So you are involved in a fairly new large research project called IceLink, linking observation and models on the North Atlantic ice sea. Could you tell us a little bit more about this interdisciplinary research and why this is important for Arctic communities?
Yes, thank you. So this is quite exciting. So we got European Horizon funding starting in 2025, this project of 11 institutes in Europe, 7 countries, and the focus is on Greenland ice sheet, and the Icelandic glaciers are used as a laboratory, really, for Greenland in a warmer climate. So we are drawing upon experience of the researchers who have been doing a lot of work in Iceland and the Greenland, and we have all the institutes in Copenhagen that are working on the Greenland ice sheet, and we are combining, so we are not only combining the observations and the models, but we are also trying to combine also the local stakeholders and the people who are working in those different regions to ask them, and they are kind of in consultation with the people there. We are asking what kind of information is important for you and how can we provide that information, because I think some of it is really hard to interpret, and we are collecting the information, and the models are improving with using the information from the observations. But then it shouldn't be sitting on our computer, but we really want to discuss and involve the local people, the stakeholders, and the communities to actually engage with the data and the results that we are getting from that project.
That sounds really interesting. And something similar is happening on your front, Hanne, in Svalbard. You mentioned in your opening remarks a project that you are leading, which might actually give the communities, the Arctic communities, some tools to work with when it comes to resilience adaptation. Could you please elaborate more about that?
I can. Yes, it's a very nice question, also because, of course, this is taking action, and we just heard today about missing solutions. I wouldn't maybe not call it a solution, but more an adaptation, but also, of course, building resilience in a small community. In 2016, there were quite warm summers, 17 as well, and that meant that we had much thicker active layers and saw quite intensive landsliding in October. And this, of course, got us all to understand that we need to have much better data access. Of course, you collect your scientific data, but we need them to be online and available. And so we started some work to actually develop a platform that collects all this data. And it sounds like something you do in an afternoon, but it's not. It's something that takes some funding and some time. So now we are actually finally got some funding from the Norwegian Research Council to actually start developing such a platform. And that is a very interesting work, because I, as a natural scientist, I know which kind of data I want there. But now I'm also starting to discuss with my science partners in social science and politics and so on, and they have like completely other things that they need to have in this platform. And we've never done it before. Such a platform doesn't exist, so it's innovation. And we are even discussing the process of developing it. How do we actually accommodate the wishes from the local government, the local communities, the local companies, and so on, in terms of what should be in that platform? And then we have also some research partners that want to use it to develop machine learning tools and so on, so that we can actually also go back in time and use the data and start predicting when this and this happens, in terms of, for instance, a rainstorm coming in. Maybe there's a higher risk for this and this, so that the system can get trained and become clever by itself and actually provide a tool to the community to say, oh, here's a special situation, and you maybe need to do some things now. This is quite important, because we have also in the Arctic community of Svalbard, no indigenous, definitely no indigenous population, but a very high turnover. So it means that the people that administer this place, they have maybe new. We have just seen like someone coming in, they have 14 days of experience and need to handle a situation like this. So if they don't have tools like this, it can go very wrong. So I would say we have quite high ambition, and therefore, of course, also take our time to develop this the best possible way. And this includes everything from permafrost temperatures and how much water is in the ground, what is the meteorological data at different parts of this small settlement of Longyearbyen, with the ambition being that we develop a system that's developed, yes, to that place, but it should also be exportable. It should be something that a community in, let's say, Arctic Canada on permafrost could also at least see how it's done, and they could implement it where they are. So I would say ambitions are relatively high. We've also recently held a meeting with, like an information meeting to explore and explain to people, what is this and what do you want as a local citizen? And of course, there was also a lot of brand new people who didn't know anything about this and who wanted to, understand things, but there are also people with a longer period of living there that wanted to, can we please have data on the runway? This is an important critical infrastructure. What do you know about that? So it's a huge process, but it's also very interesting, and it needs to be interdisciplinary to address the needs.
Thank you so much. And one automatically thinks when you point out that there is a high turnover of people in Svalbard, that you can have let's just put it, a very high turnover of people when it comes to tourists. So I guess that these tools might also apply to that. But I thank you so much. I want to divert the focus a little bit. We have a lot of knowledge on climate change processes, impacts of climate change. We've heard some of it here today. And these two really interesting interdisciplinary research projects. But we are still always faced with the challenge of disseminating our knowledge and get a response to correct the course, if we can put it that way. And I think this is particularly important when it comes to something as dire as climate change. Now, Dr. Árnason, Þorri, I'm always going to call you Dr. Árnason from now on. You have used photography, you have used filming, methods that I don't understand to visualize the past and the future of glaciers through visual research. But is it enough to have fancy cameras and cool computer programs? And I know your cameras are very fancy, I've seen them. So what, in your experience in communicating your work, and what is your experience in communicating your work? If you could elaborate briefly on that, and also what kind of research do we need to learn what kind of methods are most valuable when it comes to dissemination of information? Just a short and easy question for you, my friend.
Yes, thank you, my dear friend Mummy. Well, I think the key answer to these questions is quality. We need scientific research of high quality. That is always going to be the foundation of quality communication. I make a certain distinction about information dissemination and communication. So a lot of what we do as scientists would fall under dissemination. This is partly because of the channels that are open to us, but there's also pressures from our culture to produce outputs in certain formats, which unfortunately, despite the fact that they're very valuable as such, peer-reviewed articles and book chapters, etc., are not very conducive to communication to our lay public. To my mind, there are two spheres that we need to consider in our efforts of communication. One, of course, is the public, to which we have a strong responsibility. I am a public servant. I've been one for 3 decades or more. I take my responsibility towards the public very strongly as an academic. But we also, the question is, if we want to have influence, we need to somehow interact with policymakers. And I've had some experience of working for the government in the so-called Master Plan for Nature Conservation and Energy Utilization, which until recently gave me hope that this was possible. I totally agree with Tolly that scientists need to be in the forefront when policies are being made to deal with climate change and similar catastrophes. So to get back to your question, the good thing about the down-wasting of glaciers is that it's a very visual phenomenon. And when I started working with Kieran Baxter and Guðmundur Pálsson and others, this was something we knew or had noticed. And if you want to talk about the visual research, you can first of all talk about the research methods or the apparatus you use, which are different kinds of cameras. You can talk about the nature of the subject matter, that this is something which is inherently visible. But then the third element is visibility. How do you can have you can have the best cameras in the world, you can have the best science to work with, you can have fantastic communicators, but if you don't have a platform, then nobody's going to see all of this. So these are sort of interconnected questions. One example that we were very hopeful with and still retain some hope for was a short film called After Ice that Kieran directed and I co-authored and produced. We released this in 2021. We decided that this film should be in open access. This should never be behind a paywall. And we also decided to make some of the key elements of that film available for use for others in the spirit of open access. And although the film in its entirety has not maybe had as many screenings as we'd hoped for, the fact that we had this open access element has led to pieces of it being taken up by media outlets, by documentary filmmakers. The latest example was that on the, as you call it, Tonight Show with Stephen Colbert, there was a short segment of After Ice shown as part of a documentary that is coming out on Netflix. So bits and pieces of After Ice have come before the eyes of millions or even tens of millions of viewers. We need to step up our communication hugely. And one thing we need to do alongside that is we need to do reception studies. We need to know whether the messages that we're crafting, whether as scientists or communicators or artists, are actually getting through, having something like the desired effect. So this also then brings us back to interdisciplinarity. We need to have much greater collaboration between scientists and artists, but within the sciences, we need much stronger collaboration between the natural sciences and the human sciences. And human sciences, talking both about the humanities and various social sciences, not in the least psychology. Does that answer your question?
Yes, thank you so much. Yeah, and if I may, just before you go, John, because I wanted to direct a question to you following up on this, because we are experiencing this high urgency in almost every message we hear from the scientific community. So what is it we are doing wrong in our communication? Could you please help us, having your experience, having advised presidents, et cetera, why people are not responding and why governments are not responding? And maybe put it this way, what can we do to communicate better?
Well, first of all, you've already heard quite a few of the answers from my colleague, who just gave a great account of much of what is necessary. But I wanted to add a couple of things which relate to your questions. I give an awful lot of talks to science groups, and I always get asked at the end, what more can we do? And my answers always include the following. I say, every person working on these issues needs to consider dissemination part of their responsibility, as our colleague has noted he has done. We all have to take dissemination as a part of our responsibilities. And we have to get better at it. We have to get better at clarity, that is, explaining these matters, particularly in their scientific respects, at a level that's cognizant of the likely scientific level of the audience, not full of jargon, not full of extremely complicated explanations that most of the audience will not follow. We have to use pictures. We have to use specific examples that are linked to the interests of the audience, to the lived experience of the audience. You have to make the connection between the science you're talking about and things that your audience actually cares about. And you have to always end with a discussion of what people can do. You cannot afford to paralyze people with a lot of knowledge about what is happening without providing them with some pathways that they can take to reduce the dangers, to address the issues. The other thing I would say is that we're not doing quite as badly as your last question suggests, in that what polls show around the world, continuing polls, is that between 70% and 90% of publics all around the world already believe climate change is real, that it's caused by humans, that it's already doing damage, and that governments need to do more about it. Those things are accepted by an extraordinary percentage of publics around the world. It's about 70 to 75% in the United States. In both Brazil and China, it's 88 to 90%, by the way. The problem is that there is not agreement on exactly what to do about it, which is partly the result of us not spending enough time on talking about solutions. And it doesn't have quite enough priority compared to the top issues, which are what's happening to my income, what's happening to my health care, what's happening to my ability to educate my kids. The good news is that climate change used to rank number 18 or 19 on the list of priorities for Americans, the questions that keep them awake at night. It's now come up to 7 or 8, number 7 or 8 rather than 18 or 19. So we are making progress, certainly in the United States, but I think elsewhere. But a countervailing force is that we have an extremely pernicious geopolitical environment at the moment, where what is being emphasized is power, domination, getting your way, and these ideas are being propagated by some people who do not want to recognize that climate change is a danger of the same magnitude as nuclear war, as global pandemics, as AI, the other things that people are really getting excited about. None of them are more important as a threat to the civilization we know than climate change. We've got to get that across to get it from number 7 or 8 to number 2 or 3 or 4.
Thank you so much. It's actually happened here in Iceland, 2021, before the elections that year. Environmental issues environmental issues were ranked number 1 and 2 alongside health issues, but then it dropped down to, what was it, 5th or 6th, something like that, in the election last year.
The Icelandic public is still smarter than the American public.
Okay, so we will end on these good notes. No, but seriously, guys, time is up. This goes very fast, like always. I want to thank the panelists for their deep insights. We have gathered information here on interdisciplinary research that is very much capable of helping us in dealing with the dire effects of climate change in the Arctic, and I think beyond as well. Keep up your good work, and looking forward to the rest of the conference.